This is Vijay Krishna from Assistant Professor in Mathematics, Department of Applied Sciences and Humanities. Today, I am going to give some lecture on Jacobian, which is very important topic in the second mid syllabus of LA&C subject. Okay, so what is a Jacobian? How to calculate Jacobian? What are the properties of Jacobian? We have to learn, right? So for that, welcome to the LA&C class. Now, here Jacobian. So this is the definition of Jacobian. So clearly here, if u comma v are functions in terms of x and y. So clearly u comma v are functions in terms of x comma y. Then their Jacobian of u comma v with respect to x comma y is denoted as j of u comma v by x comma y, or dou of u comma v by dou of x comma y. So and it is defined as determinant of ux, uy, vx, vy. Right? So here formula is Jacobian of u comma v by x comma y, or dou of u comma v by dou of x comma y equal to det of ux, uy, vx, vy. So this is the formula for Jacobian. Okay, so this is the definition and formula of Jacobian. I think I understood. So now coming to the properties of Jacobian. Okay, so we have two properties of Jacobian are there. First one is if j equal to j of u comma v by x comma y. Okay, right. So now j of u comma v by x comma y means Jacobian of uv with respect to x comma y. So here another Jacobian j dash, that is Jacobian of x comma y by x u comma v. Here Jacobian of xy with respect to u comma v means here the functions x comma y should be in terms of u comma v. Here the first function, first Jacobian of u comma v by x comma y, here we calculate the Jacobian u comma v should be in terms of x comma y. Right? So these are the Jacobians. When their product is calculating, the product is clearly 1, j into j dash equal to 1. So this is the first property. If Jacobian j is j of u comma v by x comma y, and j dash is Jacobian of x comma y by u comma v, that is reverse Jacobian. So when we calculate their product, it should be equal to 1. So that is the first property. Right? So now coming to the second one, u comma v are functions of r comma s. Right? And r comma s are also functions in terms of x comma y. Clearly, u comma v functions in terms of r comma s are functions in terms of x comma y. Then Jacobian of uv by xy equal to Jacobian of uv by rs into Jacobian of rs by x comma y. So this property is known as chain rule of Jacobian. Okay, chain rule of Jacobian. Now coming to the problems, here I am going to explain one problem related to the Jacobian. Okay, clearly here given x equal to u into 1 plus v and y equal to v into 1 plus u, then we have to prove that dou of x comma y by dou of u comma v equal to 1 plus u plus v. Okay, so now take the given, that is x equal to u into 1 plus v and y equal to v into 1 plus u. Calculate their first ordered partial derivatives. Okay, so xu. What do you mean by xu? Xu is nothing but dou x by dou u, partial derivative with respect to u. So here we have two variables u comma v. When we differentiate with respect to u, treat the other variable as constant. So here differentiation with respect to u means the variable v as constant. So 1 plus v is completely constant. Remaining in x is u. Okay, so derivative of u is 1. Now coming to the xv, partial derivative with respect to v. So which variable constant? U constant. So u take outside, remaining in x is 1 plus v. Its derivative is derivative of 1 0, derivative of v 1. Okay, so now coming to the y, yu, partial derivative with respect to u. So which variable constant? V constant. So take outside V. Remaining 1 plus u. 1 plus u derivative of 1 is 0, derivative of u is 1. Okay. So now coming to the yv. Partial derivative with respect to v. So which variable constant? U constant. So 1 plus u take outside. Remaining v. Its derivative is 1. Okay. So finally we got xu, xv, yu, yv. So now we want to prove the dou of xy by dou of uv equal to 1 plus u plus v. So if you want to prove that, first we have to take LHS. What is LHS given? Dou of x comma y by dou of u comma v. Okay. So write the formula for Jacobian. Here xu, xv, yu, yv. Okay. Now substitute all the values. Det of xu. What is xu? 1 plus v. Now xv, that is u. Now yu, that is v. yv, 1 plus u. Okay. So when we observe the determinant, clearly it is det of ABCD. We know that how to calculate det of ABCD. Simply AD minus BC. So 1 plus v into 1 plus u. 1 plus v into 1 plus u minus v into u ante v uv. Okay. So now multiply both the brackets 1 plus v into 1 plus u. First multiply with 1 to the 1 plus u, we get again 1 plus u. Now multiply with v, v into 1 v plus v into u, uv minus uv. Minus uv plus uv cancel. Then we have 1 plus u plus v. Clearly it is RHS. Okay. So LHS equal to RHS. Finally we got dou of xy by dou of u comma v equal to 1 plus u plus v. Okay. So I think you understood how to calculate Jacobian. Right. Now coming to the second problem. Coming to the next problem. If u equal to x plus y plus z, comma y plus z equal to uv, z equal to uvw. So then evaluate dou of xyz by dou of uvw. Means that we have to calculate the Jacobian of xyz with respect to uvw. So means that we have to calculate the xyz functions in terms of, should be in terms of uvw. Okay. So when we calculate the Jacobian of xyz with respect to uvw, the functions xyz should in terms of uvw. So first we have to convert them in terms of uvw. Right. So when we observe the given u equal to x plus y plus z and y plus z equal to uv and z equal to uvw. Right. So when we observe the given, clearly the function z is also in terms of uvw. So remaining we want to convert in terms of uvw. They are x and y. Okay. So for that substitute the z value in y plus z equal to uv. Okay. Right. So now y plus z value uvw equal to uv. Then y equal to uv minus uvw. So take uv common, then 1 minus w. So finally we got y in terms of uvw. Right. Now we have to calculate the x value also in terms of uvw. So for that take u equal to x plus y plus z. Right. So already we know that y plus z equal to uv. Substitute y plus z value here. Then x plus uv. Right. So by this one x equal to u minus uv. So take u common, then 1 minus v. So finally we got x equal to u into 1 minus v and y equal to uv into 1 minus w and z equal to uvw. So when we observe the x, y, z, now they are in terms of uvw. So now calculate their partial derivatives which are of first order. Right. So now xu xu means dou x by dou u. Okay, so how to calculate dou x by dou u? Here dou x by dou u means partial derivative with respect to u. So when we differentiate with respect to u, remaining variables v and w are constants, right? So when we observe the x, that is u into 1 minus v, completely 1 minus v is constant, take outside, remaining u derivative 1. Now calculate xv, partial derivative with respect to v. So u and w are constants. So in x, u is constant, take outside u, remaining 1 minus v. Derivative of 1 minus v, one derivative is 0, derivative of minus v is minus 1. So finally we got minus u. Okay, now xw. So when we observe the x, there is no w. So x is u into 1 minus v, there is no w. So when we differentiate with respect to w, remaining two variables u and v are constants. So the derivative of u into 1 minus v is 0. Okay, now coming to the y. So y equal to uv into 1 minus w. Calculate yu, partial derivative with respect to u. So v into 1 minus w are constants, take outside, remaining u derivative 1. Now yv, here in y, u into 1 minus w are constant, take outside, remaining v derivative 1. Now yw, so when we differentiate with respect to w, uv are constants, so take outside uv, remaining 1 minus w derivative, derivative of 1 is 0, derivative of minus w is minus 1, that's why we have minus uv. Okay, so now coming to the zu, partial derivative with respect to u. So v and w are constants, so vw take outside, remaining u derivative 1. Then zv, similarly zv with respect to v, so uw are constants, take outside, remaining v derivative 1. Right, now zw, so differentiation with respect to w, so u comma v are constants, take outside uv, remaining w derivative 1. Okay, so finally we got xu, xv, xw, yu, yv, yw, and zu, zv, zw. They are first ordered partial derivatives. Okay, now write the formula for Jacobian. What is a Jacobian? So Jacobian of, that is dou of x comma y comma z by dou of u comma v comma w. Okay, so we know that the formula Jacobian. So det of xu, xv, xw, yu, yv, yw, zu, zv, zw. Okay, right. So now substitute all values. Xu, what is xu? Xu is 1 minus v. Okay, so now write here 1 minus v. Now xv, that is minus u. Okay, now xw, that is 0. Now substitute remaining yu, that is v into 1 minus w. Now u into 1 minus w. Next yw minus uv. Okay, now zu vw, zv uw, zw uv. Okay, so calculate the determinant by using first row. Okay, what are the first row elements? 1 minus v, minus u, 0. Right, so now write the 1 minus v, that is first element. Okay, now write the minor of 1 minus v. If you want to calculate the minor, simply leave the row and column which being that element. So clearly 1 minus v in first row and first column. So leave the first row and first column, remaining elements u into 1 minus w minus uv, uw, uv. Okay, now minus, coming to the second element, that is minus u, so plus u. Okay, so minor of second element. What is minor of second element? Leave the which row, which column? Clearly minus u is in first row, second column. So leave the first row and the second column. Then we have v into 1 minus w minus UV, VW, UV. Okay, right. So remaining third element is 0. So 0 into minor of third element is 0. So leave that one. So now calculate the value 1 minus V into here. Det of ABCD, AD minus BC, we know that U into UV, U square V into 1 minus W, minus into minus plus U square VW, okay, plus U into V into 1 minus W into UV, we get U V square 1 minus W, okay, plus U V square W. Now simplification. First, U square V into 1, U square V, U square V into 1, U square V, U square V into minus V, minus U square V square. Okay. Now here U square VW, U square VW into 1, U square VW, U square VW into minus V. So minus U square V square W. Now here U V square into 1, U V square into U. Plus U square V square. So U V square into minus W minus U V square W. So when we multiply with U, we get minus U square V square W. Now multiply with U, U V square W. We get U square V square W. So minus U square V square W plus U square V square W cancel. So now here plus U square VW minus U square V square and plus U square V square cancel. So then what was the common? U square V plus U square VW minus U square VW. Okay. So both are cancelled. So then we have U square V. Right. So this is the answer. Okay. So now I am going to explain next topic. Functional dependence. Okay. So what is the functional dependence? Suppose U comma V be two functions in terms of x comma y. Then if their Jacobian is vanishes, means their Jacobian is 0, then the functions U comma V are said to be functionally dependent. If their Jacobian is not 0, then they are functionally independent. Okay. Simply, if the Jacobian of two functions is vanishes, that is 0, then the functions are said to be functionally dependent. If Jacobian of two functions is not 0, then the functions are called functionally independent. Okay. Now coming to the one problem, show that U equal to sin inverse x plus sin inverse y and V equal to x root 1 minus y square plus y root 1 minus x square are functionally dependent and find their relationship. Okay. So take U equal to sin inverse x plus sin inverse y. Okay. So now calculate ux, partial derivative with respect to x. With respect to x means y constant. So derivative of sin inverse x is 1 by root over 1 minus x square. So derivative of sin inverse y is 0. Now uy, partial derivative with respect to y. So x constant. So derivative of sin inverse x is 0. Derivative of sin inverse y 1 by root over 1 minus y square. Now take v, that is x root 1 minus y square plus y root 1 minus x square. Okay. Now vx, partial derivative with respect to x. So y constant. In v, root 1 minus y square is completely constant. Remaining x derivative 1. Right. Here y constant. Now differentiation of root 1 minus x square is 1 by 2 root 1 minus x square into its derivative is minus 2x. So when we cancel the 2, we get root over 1 minus y square plus into minus minus xy by root 1 minus x square. Okay. Now we got ux, uy, vx. Now coming to the vy differentiation with respect to y. So means x constant. So in x root 1 minus y square, x constant take outside. Remaining root 1 minus y square derivative 1 by 2 root 1 minus y square into its derivative, its inner derivative minus 2y. Okay. Now plus in y into root 1 minus x square, root 1 minus x square is constant. Take outside root 1 minus x square. Derivative of y is 1. So here 2 cancel. Then minus xy by root 1 minus y square plus root 1 minus x square. Okay. So we got ux, uy, vx, vy. Now calculate their Jacobian. So how to calculate Jacobian? We know that Jacobian of u comma v by x comma y formula det of ux, uy, vx, vy. Okay. So now det of ux. What is ux? 1 by root over 1 minus x square. Okay. Vx can be written as root 1 minus y square minus xy by root 1 minus x square. Okay. Now write uy. What is uy? 1 by root 1 minus y square. Now vy is nothing but root 1 minus x square minus xy by root 1 minus y square. Okay. So now find the determinant det of ABCD. We get AD minus BC. Okay. So 1 by root 1 minus y square into this one. 1 by root 1 minus y square into root 1 minus x square is 1. Okay. 1 by root x square minus xy by root 1 minus y square is minus xy by root 1 minus x square into root 1 minus y square. Okay. Now minus 1 by root 1 minus y square into root 1 minus y square 1. Okay. So minus into minus plus 1 by root 1 minus y square into xy by root 1 minus x square into root 1 minus y square. So when we observe the here minus xy by here plus xy by cancel. Here plus 1 minus 1 cancel. So finally we got 0. Okay. So clearly Jacobian of u comma v by xy equal to 0. So when Jacobian of two functions is 0, then simply they are called as functionally dependent. So u comma v are functionally dependent. Functionally dependent. Now we want to find their relationship. Okay. Right. Now observe the given u equal to sine inverse x plus sine inverse y. Okay. So in intermediate there is inverse trigonometry functions. There is one formula. Sine inverse x plus sine inverse y is nothing but sine inverse of x root 1 minus y square plus y root 1 minus x square. Okay. Then sine inverse of what is x root 1 minus y square plus y root 1 minus x square? It is nothing but clearly v. So u equal to sine inverse v. Then we get sine u equal to sine of sine inverse v. So sine of sine inverse v is v. So finally we got the relationship as sine u equal to v. So this is the relationship. Okay. So clearly the given two functions u comma v are functionally dependent and their relationship is sine u equal to v. Okay. Clear? So now, I think you understood what is the Jacobian and how to calculate Jacobian and how to calculate functionally dependence. When so now coming to the assignment. So here u equal to x square minus 2y, v equal to x plus y plus z, and w equal to x minus 2y plus 3z. Then we have to find we have to find dou of u v w by dou of x y z. Okay, this is the first problem, right? So here we have to calculate the Jacobian of u v w simply, right? So now second problem related to the functionally dependence, right? So they are given u equal to x by y and v equal to x plus y by x minus y. Simply we have to check their Jacobian is 0 or not. If it is 0, then they are functionally dependent. So when they are dependent, calculate their relationship. Okay, so this is assignment to you, right? Thank you very much, all of you.